Hey there guys, welcome to my channel. Today we're going to be solving a nice Diophantine exponential equation where we have 8 to the power of n minus 2 to the power of n all divided by 6 to the power of n minus 3 to the power of n equals 2. And we want to solve for positive integer values of n. Cool, so let's go ahead and do that. In order to do that, first of all, notice that 8 is 2 cubed. So I can replace 8 with that and say that we have 2 cubed to the power of n minus 2 to the power of n, all divided by, so I can replace 6 with 2 times 3 to the power of n minus 3 to the power of n, and this equals 2. Cool. Next, let's go ahead and multiply these two and distribute this power. So we're going to have 2 to the power of 3n minus 2 to the power of n, all divided by 3 to the power of n times 2 to the power of n minus 3 to the power of n equals 2. Next, let's go ahead and factor out 2 to the power of n on the top of the fraction. So we're going to have 2 to the power of n times 2 to the power of 2n minus 1, all divided by, and in the bottom, let's go ahead and take out 3 to the power of n. So we're going to have that, and this equals 2. Cool. Now, if you look at the top of the fraction, you can see that we have a difference of 2 squares over here because we have 2 to the power of n times 2 to the power of n squared minus 1 squared. And that means that we have a difference of 2 squares on the top. Great. So let's go ahead and factor it out. We can factor the top into 2 to the power of n times 2 to the power of n minus 1 times 2 to the power of n plus 1. And this is divided by 3 to the power of n times 2 to the power of n minus 1. And the whole fraction is equal to 2. Cool. Next, let's go ahead and cancel this with this. So we will have 2 to the power of n times 2 to the power of n plus 1 divided by 3 to the power of n equals 2. If we cross and multiply, we're going to have 2 to the power of n times 2 to the power of n plus 1 equals 2 times 3 to the power of n. Now, notice that since we want to solve for positive integers, n should be something greater than or equal to 1, right? And if n is greater than or equal to 1, I can go ahead and say that this is even and this is odd. On the other side, we have 2, which is even, and 3 to the power of n, which is odd. So by comparing both sides, I can go ahead and say that 2 to the power of n should be 2, and 2 to the power of n plus 1 should be 3 to the power of n. From the first equation, we're going to get n equals 1, and since n equals 1 does satisfy our second equation because 2 to the power of 1 plus 1 equals 3 to the power of 1, therefore we can say that n equals 1 is a valid solution, and actually that's the only valid solution that we have. Great, so this brings us to the end of this video. Thank you for watching this video. Please consider subscribing for more contents like this, and hit the like button if you enjoyed watching this. Hopefully I will see you later. Goodbye for now.